I'm assuming now everybody's cluster is fine and you have created a 3 node cluster. So I will be taking forward from where we left on the service understanding front. So we had already started with HDFS, and just a quick recap. So okay, before quick recap, let me just start my cluster. I think this instance can be terminated now. Linux practice, don't need it anymore. So let's first terminate this. Linux, I think shell scripting was when we had started it, we faced some difficulty with the recording. So we will be discussing it again, probably after we complete yarn. Okay. So, and we can practice that on any of these 3 nodes as well. So we don't need this free instance anymore. Okay. So that's being said, let's start the cluster. And again, the same thing, I will go to security groups and change my inbound. So I had made it, you know, available to everyone because some of you had to download the packages. So that's why I made it available to everyone. But for today's class, I'm again making it my IP. Okay, let's get back to EC2 and connect to one of the instance. All right, so let's come back to HDFS as a service. So let's open the cluster before that. So immediately when you will be logging in, you will see, everything is unknown with unknown status, unknown health, all these things. And see the graphs as well. The reason is that the Cloudera management service is down. Okay, because we had already stopped it. So we have to start it every time you start the cluster. Okay, so now I can see statuses. Some of it is showing bad health, and some of them are yellow. That means something is still concerning about it. But yes, these bad health or critical issues, we should get them solved. One of them is under replicated blocks. That's basically part of the HDFS understanding. When we get through that concept, we will fix it. Okay, so let's get into HDFS and check what are the instances showing in here. Okay, so we can see name node, secondary name node, and data node, and also something called as a balancer. This we will discuss a little later, but yes, these three are the core components of HDFS, and that's what we discussed initially when we started with this. Okay, so HDFS, it's a Hadoop distributed file system. It's the storage concept of the Hadoop. It's the service which manages the storage of data in a distributed fashion. Okay, so any file that we want to write into the HDFS, it will be first divided into blocks. Okay, so we discussed how HDFS actually works at the back end. So whenever you want to store a file, it's first divided into blocks of equal sizes. Since we are calling it a distributed system, that's why the files should also be distributed. It should be divided and distributed among the different locations or different servers which are part of the Hadoop cluster. But the size of the each block, it is going to be same, and it's going to be 128 megabyte. You can change it. Okay, by default, this is what they have decided, and this can be changed. Now you can see even the smallest unit of a block is around 128 MB or megabytes. Although when we talk of in terms of storage, the smallest unit is bytes, right? The reason we have chosen this amount is because we are dealing with big data. We are expecting our data or our files to be very big, and that's why we are taking the smallest unit of storage in Hadoop, which we call block, to be of that much size. Okay, if somebody or some company is dealing with even larger data sets, they can increase this value to a little larger value also. Okay, but by default, this is the size which each block will have. Okay, we also discussed about some example. Let's say this is the file which is having this much size. So we want to store it. So we will be actually be storing divided into 100 blocks and then storing these blocks in a distributed way. Now then we talked about the architecture of this service. Okay, so all these components that we see here, name node, secondary name node, data node, they're basically part of this architecture. The actual blocks, so these blocks, their actual storage depends on the data nodes. So where you have data nodes, you will have the blocks stored over there. Okay, this service is responsible. This role of HDFS, called the data node, is responsible for storage of blocks. Okay, so this is where you will find those blocks stored. Next is name node. Now name node, this is basically a master role. It doesn't actually stores these blocks or data, but it stores the information about blocks, about data nodes. So in all, it's a kind of a master service. These are data nodes are slaves. The master knows what each slave is doing and what each slave has stored in it. Okay. So name node is going to be the role which is just in storing the information about which data node store which block, which data node is active, which data node is dead. So all those kind of information that's being stored on the name node, and this information is also called as a metadata. Metadata means data about data. Okay, so all these nodes are storing some data. They are also up and running. All this kind of information is available with the name. Okay, so also secondary name node. So since we are saying that name node is our master, now every time a client or anybody who wants to write some data on the cluster, they must first contact the name node, because name node will then tell him that okay, you need to distribute the file into blocks, and then these are the servers where you have to store the information. Okay, so every time any client wants to read or write some data in the HDFS, they will first contact the name node service. So that's what makes name node as a single point of failure. Okay, so how is it single point of failure? So let's say if this name node's role is down, it is stopped. Okay, in that case nobody can either read or write the data to the cluster. For example, if I just go to the server, let me become HDFS user. Okay, so right now more of my services are up. Name node is up and running. Data nodes are also up. Okay, so these are the two primary things which are going to manage the data storage and retrieval. So let's say I want to create a file, and I will be writing something into this file. Okay, and now I am going to write this into the HDFS. So the command, whenever you want to put a file into the HDFS, we discussed that earlier also, is HDFS DFS hyphen put test dot text, and I'm going to put it into the temp folder of the HDFS. Now you can consider HDFS as a big server, okay, as a big single server, but actually at the back end you have all the data nodes that combine together to form that. Let me just put this file first, then I'll explain it more. Okay, so now this file has been placed. Now if I have to do ls, just like how we used to do ls on the server, I will do it like this. Okay, so now I can see the test.txt file is there in the temp folder. Now this temp folder is not on this server. If I have to check the temp folder of this server, I will simply do ls/temp. This is my local server, but this ls we are doing actually on the HDFS. Okay, so HDFS is basically a distributed file system. So this temp folder is not on any single server, although right now it's available on single data node only, because we have only one data. But as and when I will start adding more data nodes, okay, this temp will get distributed among each of them. So all these files are not on a single server, but they are basically divided and present on a different, on will be present on as many data nodes as you have, depending upon their size. Definitely, if it's greater than 128 megabytes, then only it will be divided into multiple blocks. Otherwise, it will be stored on that server itself. But one thing to understand is when we are doing HDFS, DFS, and then we are doing ls, this is basically we are querying the Hadoop file system, and we are not querying any single server, just like this. Okay, so the point was I could write a file to the temp. I could do ls also to read information about the temp. Now, if I just stop my name node, although there is no data which is stored on the name node. Okay, so now it is appearing as stopped. Let's try to do the same ls on temp again. So it says connection refused, not able to connect to this server. This server is basically our name node, and the port over which the name node runs is 8020. So this is about ls. We cannot put the file again. So let me make a copy of that file. Let's call it test2, and let me put it and try to put it again. And again, same error, connection refused. So this name node is actually our single point of failure until and unless this service is up and running. Even though my data node is running, but since my name node is stopped, I cannot do anything further. Okay, so that's why in this architecture I have shown that client will first contact the name node, which will then tell him to store the data on any one of the data nodes. And this is where the secondary name node also comes into picture. Now let's say this server is not just stopped. So on the server on which this name node role is running, that is just not stopped, but it's also we are not able to recover it back. Somehow we have lost this server on which the name node role of our HDFS service was running. Now what? Now how will you recover your data? How will you get the information about the data that you already have in the cluster, because everything else is showing this error. So in that scenario, we might want to recreate this name node service on some other server. Okay, so as
I
an admin, hello,
I do have a one question.
yeah,
So if the active name node is stopped, isn't it the secondary name node act as an active name node
no,
and we are
no,
get the data?
no. See, there are two scenarios in HDFS. Basically, the thing that you're talking of that exists, but we'll talk it in a little while. It's called highly available. Okay. Right now we are dealing with this architecture which is called a non-highly available architecture. Okay, so this is a non-highly available, wherein secondary name node will not replace the name node. It is just as a backup or as a name node that's keeping track of all the information that the active name node has. Okay, so secondary name node will not take place of name node in case the name node goes down. There is another architecture which is called as a highly available, in which the secondary name node will actually be replaced by name node itself, but in that case that name node will be a standby name node. We will discuss that too. Okay, so this is basically a scenario wherein you just now have installed HDFS. So by default, every time you install HDFS service, it will first come into a non-highly available environment. Then further you can make it highly available, which we will also be doing it. But before that, you should understand what exactly this secondary name node do in a non-highly available environment. My client will not talk in any way to the secondary name node, nor will this secondary name node talk to any of the data nodes. You can see there is no line between the client secondary name node and secondary name node as data nodes. There is just a connection between name node and secondary name node. Okay, so let's come back to this. I think this answers your question, right? Okay,
Yes.
so let's come back to this. And so let's say this name node is lost. We are not able to make this server started again somehow. In that case, this secondary name node will come into picture. And what the Hadoop administrators and you guys will do in that case is you will copy the information from secondary name node on another server which is up and running, and you will make this name node service installed on that other server, and you will start it so that it will pick up that information and get the complete cluster back. Little complex to understand right now, but yes, when you get more into HDFS, you will find it pretty easy. So first of all, let's understand what files or what information was actually being stored by this name node, and how does secondary name node helps in recovering that. Okay, so name node, all the information about which files does the cluster has, or which data node store which block, all this information the name node stores on its server in basically two files. One is fs image, other is edits. Okay, so these two files are the one where in which name node store all this metadata. Now where will you find these files? That we can figure out from our configurations. Okay, so it's called name node data directories. So dfs/dfs/nn is the location. So this is a local server location now. This is not in HDFS. Okay. So I will go to my instances again. I will see on which server do I have the name node service running. So I think right now everything is running on 176 because when we initially created the cluster, we had only one server. So at that time, every instance, every role was installed on the same server. And right now on the same server itself. So I will go to that location. Let's do ls over that. So /dfs/nm. There is another folder inside which is called current. Let's go in and do ls over that also. Okay, so now you can see some files. Okay, so what files do you see? One is an fs image, other one is edits. Yeah, definitely there are certain numbers, certain versions that you can see. The smaller version or the smaller number are pretty older. The larger versions, they tend to be pretty latest. The latest one right now is, I think, this 5430, and the latest one of fs image is also 5430. Okay, so these two files are where namenode keeps track of all the information that you have in your complete cluster. There is one more file called edits in progress with number 5431, which is definitely one more than this. Okay? But we don't see anything as an fs image 5431. Okay, we'll understand this point also, what exactly is this file. But right now, just for understanding about the secondary name node, so the same location, so all these files are present in the BFS NN. NN stands for name node location, right? Now let's say this name node was installed on a separate server, although right now we have everything on 176. Let's say it was onto some other server and it wasn't, we were not able to recover this name node. We were not even able to log into this server. So how would you recover these files? Because if you have these files, you can still recreate another name node. These are the files which store all the information about the cluster. Okay. So this is where the secondary name node will come into picture. Now, if I just again go back to configuration, I will search for FS image again. So this was my name node location. Now I want to search for my secondary name node location. Okay, somehow it's not coming up. Let me search secondary name node or SNN. Yeah. So BFS SNN. It says HDFS checkpoint directories. Secondary name node default location. So if I just go to that location also. Now I'm again saying that right now I have both the name node and the secondary name node on the same server. That's why you can see all these locations. But in your organizations which are still not on a highly available environment and you have a secondary name node, so that's definitely going to be on a separate server. So you need to log into that server and then check these locations. Okay, so right now, just for the understanding, let's assume this was on a separate server and we cannot recover or log into this server and get these files back. And secondary name node is also on a separate server, but it's still up and running. The service is running and I can still log into the server as well. So I do ls over there. I again see something called as current in the secondary name node, SNN. Okay, and you can see I have those files available in here also. But one thing you should understand, you have although these files are available in the secondary name node also, but the latest one is still not there. What is the latest one that you have in secondary name node? 5429. Edits 5429. But 5430 is not there, and 5431 is also, which is currently being processed, which is called edits in progress. This file is also not there. So in a scenario when the name node is lost somehow, but you still have secondary name node, although you can recover the state of the cluster because you have these files in the secondary name node, but definitely there is going to be some data loss because the latest file is still not there on the or in sync with the secondary name node. The only role of secondary name node in here is to keep a track of a copy of the files that name node stores. But since there is some lag, there is always some lag between name node and secondary name node. The latest FS image and the latest edits are not present on the secondary name node, and the information that you have in these files, they will be lost when the name node is lost. Okay, so this is where the Tasnimul was saying about secondary name node taking place. This is where they thought of creating an environment called as a highly available environment, wherein this secondary name node will not just act as the place of storage, but it will also act as a name node, and it will take the place of the active name node in case the active goes down. Okay, but be getting into that in a little while. First, we need to understand a little bit more about these files. Okay, so I think you can understand now. Although we can recover the name node using secondary name node, but we will still be losing some files, and that's what we will be ignoring when we become a highly available environment. But before going on to highly available, let's try to understand what exactly are these files. Okay, so edits and
Sahil,
yeah,
sorry. Sahil, we don't see the 5430 either.
yes,
Not
5431.
only the latest one.
Yeah, 5431 is edits. It's a edits latest one. You don't see that.
Okay.
FS image 30 is actually
No.
the actual latest image of the FS image. So you don't see
Okay.
5430 edits and 5430 FS image. This is something which is currently being written. Okay,
Okay.
and even this is not present.
Okay.
Definitely information which is different from 5429 and which is present in 5430 as well as in 5431, they are all lost in secondary name.
Okay.
Okay.
Okay. Hmm.
Okay, so yes, so that's where we have to understand what exactly these numbers signify, and how does they come up, how does they become. So FS image, first of all, this file is going to be the actual snapshot or the actual file which has all the complete information about the complete cluster. So we also called it as a cluster snapshot. So not just what is being written or what is being deleted from the cluster right now, but it stores from the time that we created the cluster. Okay, so it's FS image is like a complete cluster snapshot. It stores information about the cluster right from the beginning when the cluster was created. Okay, so it has complete information about what the cluster has, and it has all that information stored in a append manner. So everything starting from the beginning to what was being written right now, it gets appended in each FS image. Okay, and edits, this file stores information about a shorter time period from the previous edit file. Okay, so from the previous edits to right now what is being written, all that information will be stored in the edits file. So to make you understand a little bit more, once again. Okay, so to let you make you understand a little bit more what these files stored. Let's take an example that I created a cluster on date one. So there is some date one when I created the cluster. Okay, on date two I wrote 100 files to the cluster. On date 3 I deleted 40 files in the cluster. On date 4 I added 2 more data nodes to the cluster. On date 5 one of the data node went missing, or it stopped. all of this information is being stored in on the name node. It doesn't store the actual data. So these actual 100 files are not stored on name node. They are on data nodes. Now all of this is information. Okay. So on this day, fs image, let's say underscore 001 got created, and edits 001 got created. Okay. What does this fs image have? So it has its information that okay, the cluster is created and there are certain default files which were created in the cluster. Since this happens to be the same day, the edits also right now has the same information, okay, what fs image has. But as and when time proceeds further, now on day 2, let's say another fs image is created, and now we have edits 00. Okay, so initially we only had fs image 001 on day 2, but now we had edits 001 which was there earlier also, but now we also have a files called edits in progress with a number 002. Okay, so what does this edits in progress has? Now this edit in progress will have this information that 100 files were written to the cluster on this date, while the fs image 001 and edit 001, they have only this information that the cluster was created on date 1. Okay, so this difference of information between these two changes in the cluster, this changes could have be happened on the same day also. Okay, so it doesn't matter, I'm just giving for an example different dates. So this difference information will actually be stored in the new file edits in progress, and after a certain number of changes or certain time, what will happen is we will get into the concept of checkpointing. What does this checkpointing means? Checkpointing means you are combining the latest edits in progress with the older fs image, or basically you are writing all the stuff that you have in edits in progress at the end of this file to create a latest fs image file. So after checkpointing, what will happen is now we have again just two files, although this file can also remain. So now we have files called fs image 001 which has old information. We have edits 001 which also has old information. But now we also have fs image 002 which was basically formed by combining. This file was formed by combining okay, I'm writing it in another line. This file was formed by combining edits in progress 02 plus fs image underscore 001. And once we have combined these two files or appended the information of this file at the end of fs image, the edits in progress will now be converted into edits 002. Okay, now again same thing on this day. So now on this day we have these four files. On this day basically means on the day or on the date that we have another change in the cluster. So every time you have a change within the cluster, that information will be stored in edits in progress, and after a certain time or a certain number of transactions, checkpointing will occur which will combine the edits in progress and the older fs image to create a new fs image. Okay, so on this day again, you have 4 files already present. There is another new file being written, which is edits in progress 003. And after some time, so this information is being stored in the new file edits in progress, while fs image 002, this has all the information right starting from date 1. Similarly, fs image 001 has all the information starting from date 1, uh, but it doesn't have the newer information of date 2 that is being present in fs image 002. Okay, so fs image is an append only file. You are appending all the new information at the end of the fs image and creating a new fs image out of it. Okay, so after this you will get, when after certain time checkpointing will occur, you will again get fs image 003, and this process goes on on each change, which can be on the same day also. So it doesn't matter, this can be day 3 also. So the ultimate thing which is being written is, what is the change happening within the cluster? Okay, so that's why you see these files. This is an older edits 4723. You don't even see fs image 4723 because that doesn't need, there is a criteria that will, because this is going to be a bigger file as compared to edits, although it doesn't appear right now, but ultimately when the cluster becomes older enough, fs image is going to be pretty large as compared to edits. We only can see 5429 and 5430. These two are the, so ultimately the name node is storing only the last two latest fs image files.
Sai, I do have another question.
Yeah.
So you told us like there is a certain transaction for checkpoint, right? Is there any specific number for the checkpoints
Yes,
occurs?
I'm coming to that. Okay, so now we should understand that this is fine. Okay, there is a fs image which is older, there is an edits which is newer. Okay, so what triggers the checkpointing? Why does fs image, which is the older one, combines with the latest edits in progress? Why does it create a new fs image? So there is a criteria of to it. You can see that either there is a size. So the older fs image 5429 5430 is having about this much space. Now edits in progress has also reached about this space. Okay, so there is some criteria that decides when will fs image combine with edits in progress, and what are those criterias, or what is the situation when the checkpointing will occur. Okay, so the criterias are either the number of transactions or number of changes within the cluster. Okay, so let's say on day 3, so this is just one change, or we can say this is two changes. One is we are adding one for each data node that we have added within the cluster. Let's say we did, by default, if you do 1 million changes on any day or any instance of time, checkpointing will take place. Okay, so if you wrote 1 million files, let's say within a time span of 1 minute also, it will trigger the checkpointing, because that 1 million changes are being written actually into the edits in progress file, and it cannot handle more than that. Otherwise the file will become pretty large enough. That's why it will trigger a checkpointing, and it will combine and create an fs image instead, a new fs image instead. So this is one criteria. Similarly, we have 4 different criteria where you can trigger checkpointing. And if you want to check the default value of it, again you can check it from configurations. Let me search for checkpointing. Okay, so this property, file system checkpoint transaction threshold. Okay, so threshold means if you reach this much number, you can read about it from here also, the number of transactions after which the name node or the secondary name node will create a checkpoint of the namespace. So all these files are basically also called as a namespace, fs image and edits. Okay, will create a checkpoint of the namespace regardless of whether the checkpoint period has expired or not. So this is another criteria, we will talk about it also, checkpoint period. Okay, so one is if you do 1 million transactions, 1 million changes within the cluster, it will automatically trigger a checkpoint, and you can change this value. You can either increase it or you can decrease it. It depends upon you also. Okay, so by default it's 1 million. The other criteria is called a checkpoint period. Just below this you can see this file system checkpoint period. By default this value is 1 hour. Okay, so by default, even though if you haven't done 1 million transactions, after every hour, after every 1 hour, there will be a checkpointing. But let's say uh, within a span of 1 hour, I already do 1 million transactions 3 times. So it will not wait for this checkpointing period. It will do the checkpointing 3 times within that 1 hour. So that's what it means here, regardless of whether the checkpoint period has expired or not. So regardless that this 1 hour has been passed from the previously when the checkpoint happened, if there is 1 million or more transactions, checkpoint will automatically be triggered. So these two criteria decides when will the checkpointing take place. Okay, so these two are automatic way of checkpointing. Now there are some manual ways also which will trigger checkpoint. One is when you restart HDFS, because when you restart the name node, basically restarting HDFS means you are also restarting the name nodes, the secondary name node. So every time you restart it, it will first come to this location and check the information about the cluster from this file. And when it will see, okay, I already have an older edits in progress and an older FS image, it will first combine these two and create a new FS image and then read the information about the cluster from that one. So that's why if you restart the cluster, it will also trigger checkpointing within the cluster. And another manual way of initiating checkpointing is this command also, HDFS DFS admin hyphen same namespace. So if I would run this command, let me show you the contents. Let's try to see if we will come up with a new FS image after we run this command. So right now I can see the same thing, 5431 as the edits in progress and 5430 as an older FS image, and on the secondary name node I can see 5429. So let's try and run this command, HDFS DFS admin hyphen same namespace. I think there is a prerequisite. If I run this command, it will give me some error first. Okay, although name node is already stopped. Maybe if when I start this name node, it will also trigger FS image. So basically we are starting the master role, right? So let's first check that. Okay, this has started, although it's still showing not running. Let's try to do ls first. Okay, ls is now working fine. Okay, let's run and do the, okay, before doing save namespace, let me do ls over those two directories again. Okay, I think I still not see any change in the FS image. Maybe it didn't require to do a checkpointing yet because of secondary name node was still running. Okay, secondary name node was still keeping a track of the files. That's why it didn't do a checkpoint. Now let's try and do it using. So if we would have started the complete HDFS, it might have triggered a checkpointing. Okay, let's try and do save namespace now. So a prerequisite of save namespace is that we should have something called as a safe mode should be turned on. This is also a concept of name node. We will discuss it also pretty soon. But for the running this command right now, I will make it on manually. So to command to make safe mode on is dfs admin hyphen safe mode hyphen enter. Okay, now it says safe mode is on. Now I will try to run the command save namespace. It says successful. Let's check the locations again. Okay, can we see any difference from previous one? Okay, you can see there is one difference. Edits in progress number is getting changed. So earlier we had 5533. Before starting the name node we had 5431, right? When we had started the name node, it converted into 5553, a newer version. Although there was no combination and creation of a new FS image yet. Then when we did a save namespace, so up till here this was the case. When we did a save namespace, after that now what I can see is 5567. And you can also see an FS image 5566. So although I think that would have happened here also. Somehow it wasn't appearing. 5553 wasn't appearing, the FS image. Might be it was still in the process. But when we did a same namespace, immediately I can see a new FS image 5566, which was a combination of older edits in progress. You can see there is a timed, there is a difference being shown. So 5553 till 5566, and this was combined with the older edits 5430 and created a new FS image 5566. And also I can see a new edits in progress 5567. So although we had initiated this manually, but this will automatically also happen depending upon these two criterias. So every hour definitely it will happen, but before that hour, if there is 1 million transactions, then also the checkpointing will take place. Okay, so this was about checkpointing. I think with your clusters, just try out, try to experiment out these things, what I have done over here, and this will make your concept even more better about FS image and edits. These two are the most important topics when about somebody would ask you about name node. You should understand what exactly is happening inside the name node, and inside the name node, nothing but these two files are the ones which will take care of all the information. But yes, checkpointing is a good concept. Safe mode is also another concept we will discuss, not probably today, probably in the next class we will discuss on this. But yes, these are some of the important topics when everybody would ask you, or you like as an Hadoop admin, people will expect that you should understand these things. Okay, so try it out, practice it out on your clusters also. Uh, let's move on. Okay, any questions before that? Anything you want me to repeat?
Hey, Salil.
Yes.
Yeah, hi. After the class, if you can just show me, I have a little go over with my Movox and we have a little challenge. So after the class, maybe if you can just
Okay.
share me.
Sure.
Okay. Thank you.
Okay, so yeah, so we have discussed about checkpointing, and okay, so since we have discussed about HA also, let's just quickly discuss that too here. So this was non-HA, as I told you. Everything so far that we were discussing, they were all about non-HA environment. Now there is another environment called highly available, just what Tasnimul was talking about. Okay, so highly available environment. But now the architecture will be slightly different. So instead of this secondary name node, you will have another name node also itself. One will act as an active, other will act as a standby. Okay. As soon as this active will go down, I'm showing this with a dotted slash line just to make it understand that this. Okay, so client, as soon as the active will go down, this connections will still not be able to proceed, right? So then this connection will be initiated. And similarly, the standby name node is also will be in contact with all the data nodes. But yes, this connection is available, but it's still not initiated until and unless the active name node goes down. Okay. But yes, there is one more concept. So when first of all, let's make our cluster highly available. How will you do that? So just come back to your HDFS service. Okay, I'll take you again to the same page where you just now come back. So over here, I will click on HDFS. I will click on action. Okay. If you scroll it down, you will see this option. So enable high availability. Why should we enable high availability? First of all, because of this shortcoming that secondary name node is already behind name node. So if my name node goes down, I will lose some data. So I need an environment wherein even if my name node goes down, I should not I should not like lose some of the data which is already stored in the cluster, right? So that's why it's better to have a highly available environment instead, wherein when one name node goes down, the other will take its place. So this is a default name service. We will talk about this also. So earlier what we were doing is when we were, reading or writing a file. So if I do HDFS DFS-ls/temp, I'm basically reading it from the name node. I'm contacting the name node. So what I'm doing is something like this: HDFS:/. Then I'm giving the name node address, which is, I think this only is my name node, right? So 172.16.0.176. And since the name node runs on port 8020, so this will be the port. Okay, so when we were doing HDFS ls on the temp, by default, this was the complete address from where the ls was running. So it was contacting the name node. This is my name node IP address and this is my name node port. By default, it's 8020. Okay. So when we were doing this, so all these files are actually being referred from the name node, right? Now, when you want to have two different name nodes or two name node working as a same thing, then this won't work, right? So if let's say this server is down, this command will fail. So instead of having this thing, when we create a highly available environment, we will replace the IP address with this value. So instead of when we will complete the HDFS HA, you can replace the IP address with the name service for this value. It can be anything. If you want to make it something else, let's make it Hadoop B9 instead. Okay, so you can refer using Hadoop B9. Now what will happen is Hadoop B9 is basically it's referring to the active name node at a particular instance. So if I will be adding another name node when we do HA. Okay, so let's move ahead first. So I will give it this name service as Hadoop B9 only. I will continue. Now we have to give him another name node host. So apart from this, I will give another name node as any other server you can take. Let's take this one. Also, there is another new service called journal node, which is added to this architecture. Let me just place it over here. Okay, this journal node is also added, and the journal node will basically it will be in contact with both the name nodes, and by default you should have 3 journal nodes.
Sahil, can I ask one more question?
Yeah,
Is journal node and journal manager is the same thing?
general manager.
Yeah, like Quorum journal manager.
QGM. Okay, yes. QGM is a basically journal node service only, and it's basically storing the FS image and the edits at a common place. Okay, I'll come to that. Don't worry about it. Right now, you just need to understand that there is another something called as a journal node, which will come into the picture when you are working with a highly available environments. Okay, and by default you should have 3 journal nodes. So I will select all of the 3 servers. Why do we need 3 journal nodes is also a good question. Sometimes people ask, because of us, we want to neglect a scenario called as a split brain scenario. Okay, so when we are talking about highly available, there are a few more concepts added. One is journal node. Within journal node, we have 3 by default to avoid a scenario called split brain. We have to discuss this too. Okay, so I will leave it for the next class. All this information we will discuss more, dive more into it. Let's continue for now. Okay, so this was the default location, right? DFS NN. You can see on the new name node that we are going to add, we also have the same information. But for the journal node directories, we have to give this something new. Let's make it DFS JNN. Similarly, DFS JNN, DFS JNN. Okay, rest we will leave it as it is. We click continue. So it will take some time. It will do all these steps and it will make the cluster highly available. Okay, so Quorum General Manager, basically what this combination of these 3, it's called a quorum. Okay, and General Node or General Manager, yes, these are one another thing, and you will find them running on the 3 nodes that you choose. But what does exactly this General Manager do? General Node do? Okay, so it's like a common place of storage of these 2 files, edits and FS image. And why do we need a common place? Because now we have 2 different name nodes and they should have same information about the FS images, right? So on this name node 1, let's say if this is active, it also has the information in the /dfs/nn location, and it will do checkpointing and everything. But yes, it will also be those files will also be present in the journal nodes location, which we gave as /dfs/jnn, right? So what will happen is, why do we have to store that over there? Because let's say when this name node active goes down, the standby will become active, and then this this other name node will get that information from the journal nodes, FS image and edits, which will be latest without any data loss, and it can take ahead the work from the active name node. Okay, I think it could get a little complex right now for you to understand, so I will leave it with this architecture only and with the cluster already being into HA. In the next class, we will explore more on this. What exactly is happening behind journal nodes? Why do we need 3 journal nodes? What is a split brain scenario? How does name node active and standby work? Okay. Also, we have introduced something called as a name service, which is okay. So I was telling you that I can query a location either like this, or I can give the name service. So why do we need this name service? We need this because now we have 2 different name nodes, right? So instead of giving the IP address of the current active name node, because this will keep on changing. If this goes down, this become active. If this goes down, this will become active. So this will keep on changing. So instead of having the IP address, Now we replace it with a name service, which will refer to the current active name node. So name service, it always refer to the current active name node. Okay, so it's like an alias, you can say. It's a alias. It's kind of alias, although just for the understanding of alias of the. Okay, so I will not take it. I will not discuss anything more.
Shalil,
Yeah.
what happened if that do the secondary has it any other backup for that?
So you're talking about this one, standby one?
Yes.
Yeah, so this journal node is now the backups, right? So your FS image is not only stored on the name node, but it's also stored at a common location called journal nodes. So even though if you lost both of them, you can still recover these two files from the journal nodes. And that's the reason you have 3 journal nodes. Okay, so maybe you're keeping the one journal node is also present on the name node location, and the other is also present on the second name node. So you still have the third journal node available. Okay, so that's why we always say you should have at least 3 servers. Same is the case with data node. We haven't reached there yet. Okay, but yes, same is the case with data node. We will discuss that also. So if you lose both of them, you can still create 2 more new name nodes by referring the information from the journal nodes. Journal node is doing nothing. It's just a common location of storing the FS image and the edits in progress.
Okay, thank you.
Okay, so the cluster is now at HA. The last point I will just show you is what all services are first of all appearing. Okay, so now you can see few more services. You can see an active name node, a standby name node. You can see 3 journal nodes. There is another concept of failover controller. Let me just write it down to be discussed with HA. Okay, and you have one data node. This will remain same. We haven't added data nodes on the other side. Also, let's run the same ls using the HDFS command like this. Now you can see I can get the files like this. So this is Hadoop, and my B9 is currently referring to the active name node. If I stop it, somehow this will become active. You can practice this out on your clusters also. Okay, so I want you guys to practice few things before coming into the class next week. One thing, create and put a file in the cluster. Number 2, trigger and observe checkpointing in all the 4 scenarios. Okay, so 4 scenarios, whatever we have discussed about, you can trigger and check that. Number 3 is to enable highly available environment in your clusters. Okay, so before coming, please do these three things, practice out these three things, and try to understand these files. These are very important. If you want to read it about them from someplace else, please do that. Okay. In the next class, we will take it forward. We will discuss about safe mode. We will add 3 more nodes, 2 more data nodes. We already have the servers available. We just want to add the roles on that. And so I've already written things, I think. Yeah. And we will talk about more detailed into the active or the HA environment of the name nodes. And then we will talk about a few more admin commands. So I think we will need one more class to complete HDFS service. But yes, please practice these three things. Okay, that's it for today. Yeah, who was having issues? Shantanu?
Yes.
Okay, I'm making you the host. Others, if you want to drop or if you have any questions, you can stay. Otherwise, it's fine. We can connect in the next class. Thank you. Okay, Shantanu, I'm making you the presenter.
Okay. You can see my.
Yeah. Yes.
Okay.
Go ahead.
Okay. So here, what I was trying to connect it with AWS, and I have this message, which I know I put it the B9 in my folder, but I don't know what
Show me where
it was. I'm sorry.
just do ls. Yeah. Enter. No, simple ls. No. So do ls. Remove center.
Oh.
Hmm.
Okay.
Okay, one
Just
second.
ls.
Let me, just ls enter. Okay, I don't see B9.
Okay. So but
Show me
if
your,
yeah, go ahead.
show me your folder. Where is the file?
You see the.
Okay, it's in downloads folder, right?
Yeah.
Just copy this file. Okay, let me just take your control. Just give me the control. Okay, wait. Yeah, so this file, you need to copy it, go to the documents, mobex term, home, and paste it. Okay, now come here, do ls. You see the file?
Yeah.
Now we will do ssh. I hope IP address and everything is same. One second, let me do it.
Yeah.
Okay, so IP is 122.124.52. Yeah, 122.124.52. Now you can see another error, connection timeout. Now this is because in the, okay, first of all, let me make it. This is because the security group edit inbound rules, and this has to be my IP. It's changed. You can see that. Save. Come to the server again. Now it works.
Yes.
Okay. So just try it out.
Yeah.
Try to create cluster. Anything else we will discuss in the next class. I really have to rush now. Okay.
No problem. If anything, then I will also WhatsApp. I will.
Yeah, that is
text you
fine.
on there.
That is okay.
Thank you.
So thank you guys. If you still have any questions, anyone, you can just ping or just put it on the group. As and when I'll get time, I'll help you out. Okay. Others also. Thank you for joining. Good night. Bye bye.
Thank you. Bye.